Hello guys, and today we're gonna talk a little bit about the inverse matrix. As we know that the A is the matrix given and the A minus 1 is the inverse of the matrix. And we know that A and A minus 1 equals to I. I is the identity matrix, right? It only in the diagonals, it has 1, 1, 1, and the rest of it will be 0. And today, and not all the matrix have the inverse. For instance, if A equals 2, let's say 1, 2, or 2, 4. This one, it will not have any inverse matrix because we can see that there's something we can really see that we can find a vector X. And then with the vectors, we can get another vector of 0. Let's just try to find out what does it mean. So X should be a vector, and we should get 0, 0, something like this. And we can easily find out that this is 2 by 2, so we need a vector of 2 by 1. So this one can be minus 2. And this one can be 1. So we can see that 1 times minus 2 plus 2 equals to 0. And then below, the minus 4 plus 4 equals to 0. So why, if we have this equation, it means that we cannot really, this matrix doesn't have an inverse. It will be simple. So if we just says that it really have an inverse here, then obviously this one will equals to 0, right? Because it will be 1 by 2 by 2 time, and then 0 will be 2 by 1. So it will be 2 by 1 and it will be 0. But in this one, since A minus A inverse by A, it should be I. But we can see that if x is not equals to 0, 0, we can never find any net in this case. We can never find any numbers can make of I equals to 0. So this means that one way to detect if a matrix have the inverse or not is to say that it will satisfy this equation. And there's a way we can really use to talk about the matrix, to really calculate the matrix. For instance, 1, 5. And we want to find the A minus 1 equals to the inverse matrix. There's a way we can do it is we just write it here. And we want to make this part identity matrix, and then this one should be the A inverse. Okay, so let's see how we can do it. First, we should make this 0. So we need multiplied by minus 2. It will be 1, 2, 1, 0, and this will be 0, 1, minus 2. And the minus 2, 1. All right, that's the first step. And then we want to make this 0, this 2, 0. So it will become 0, 1, minus 2, 1, and 10 times minus 2 still be 1. 0, minus 2, 5, minus 2. So now we are done. And this matrix will be the inverse. And we can really test if it's really right. So we can use 1, 2 to 5. We use 5, 4, 2, 1. Okay, the first row A11, the first one will be 1 times 1 by 5 plus minus 4, it will be 1. And this one will be 2, 10 minus 10 will be 0. And this one, 1, 2, 2, 1, 2 minus 2, 0. And this one will be 5 minus 4, 1. So exactly, that's the way we can really get the inverse of the matrix. Why it is like that? It's actually very easy to prove. First, we have the matrix A, and here is the I identity matrix, and then what we get here is AI, and then we should figure out what is this, and then first, we can combine the EA and EI. Since EA equals to I, it means that E equals to the inverse of A. So here the EI equals to A, the inverse of A times by I. So equals to the inverse of A. So here we got the inverse of A. By the simple, proof, we can see that, okay, so if we really have from AI to I, and then this part automatically will be the inverse of A. So that's what we have done here. And then let's go to another topic about factorization. All right. So we have a simple 2 by 2 matrix. 2, 1, 8. The first 8 cannot, this one cannot be 4. 4 if it's 4, so it cannot, it's not inversible. So it doesn't have the inverse matrix of A. So we just gave it a 7. And here the conclusion is from A always can be decomposed by a lower triangle matrix and upper triangle matrix. Now, what's the lower triangle matrix? It's simple. It's something like the lower has something non-zero value and then diagonals, and all the upper one will be 0. So the upper triangle matrix will be just the reverse. All the things below the diagonals will be 0, and the upper will be something. So this one, first what we're gonna do is, like what do we have? 1, 2, and this will just times the minus 4. So it will be 0 and 3. This one already, we can see that it's already an upper triangle matrix. And then if we get an E here, and then we want to, here's U and here's A, right? And what we want now to do is to try to figure out what is this E. So we can just try to set A, B, C, D, and from this we can get A. A equals to 1. and B equals to 0. And then we go to the CD. Right? So C equals to, no, 6D equals to 6, D equals to 1, and C equals to -4. So from the equation, we get that E equals to 1, 0, -4, 1. So 1, 0, -4, 1 by 1, 2, 2, 1, 8, 7 to this one. And this one is already a lower triangle matrix. But what we're gonna do here is A equals to a U. A equals to the inverse of E times U. So here our target is to get and then we see if it's a lower triangle matrix. Okay, so let's go to this part. Get is A minus 4B equals to 1. A, it should be B equals to 0, right? A equals to 1. Okay, and let's say C and D. C minus 4D equals to 0 and C, no, D equals to 1. So C equals to 4. So here we got the matrix of 1, 0, 4, 1. And so from this one and this one, what we get is A equals to so that's our conclusion. And A can be disposed of a lower triangle matrix. Lower one means the upper, anything above diagonals will become 0, and the upper is the reverse. Anything below the diagonals will be 0. So here we can see that always a if it's inversible, it can have the inverse matrix. It can really be decomposed by two, a lower matrix and an upper triangle matrix. All right.